Hi and welcome back to my channel. Today I'm doing a COMSOL tutorial on using mesh sequences. So choosing the mesh is a great way to optimize your computational fluid dynamics modeling, whatever you're using, whether it's COMSOL or ANSYS or there's some free ones out there. I think it's called Onshape. So depending on the mesh, obviously the more detailed the mesh, the finer the computation, or the finer the resolution, and the more computing power and memory is required. So in this example, we're going to be doing the geometry from the geometry file provided on COMSOL, and that will be linked in my description. And we're going to be learning how to add, move, disable, and delete mesh operations so we can control the mesh of different features. In this example, we're going to be creating a finer mesh around the solder joints, which are the balls joining the rectangular solid portion of the circuit board and the rectangular portion of the electronic component on top. So this is modeling a small part of a circuit board soldered to a computer chip. Okay, so let's get started with the model wizard and a 3D model. And we're not selecting any physics today because it's not actually a physics study, we're just looking at geometry. For geometry, we're going to import, so under component 1, geometry. So if you have the screen full like this, then it just shows up here, but I've got a modified screen here. So if you click on geometry, it's the import button, and then go to import source. I'm going to browse for my download. I'm just going to open up the NPH or Multiphysics file that I downloaded from COMSOL earlier. Alright, and here it is. It populated the graphics window here. So if you moved around, you can see circuit board, microchip, and then the soldering joints. So under component 1, we'll click on mesh 1. And as you click the mesh 1 node, the form union feature is automatically built, which means that the various objects are combined into one object with domains separated by inner boundaries. This ensures that a continuous mesh can be created across the unconnected but touching geometry objects that make up the geometry. So with the default physics controlled mesh and the sequence type, COMSOL automatically creates a mesh adapted for the physics settings in the model. A set of 9 predefined element sizes. So if you go to the drop-down menu for the drop-down menu for element size, there's 9 levels of resolution here, defaulting to normal and ranging from extremely coarse to extremely fine. So you can control how well you want to resolve the geometry. In the model builder window under component 1, right-click mesh 1 and choose build all. Okay, so here it's built the default normal mesh, and according to the information displayed in the messages down here, this mesh consists of approximately 45,000. So mine says complete mesh consists of 46,316 domain elements, 12,544 boundary elements, and 1,434 edge elements. While the geometry is resolved quite well by this mesh, you may want to reduce the number of elements to reduce the memory required for solving the problem. So now we're going to do that. In the settings window for mesh, locate the sequence type, and we're going to change this to user controlled. Now a default meshing sequence consisting of the size and free tetrahedral 1 nodes appears under the mesh 1. So now that we've changed it to user controlled, we can change the shape and also the size of the mesh we're choosing. So first, the size is called a global attribute feature since it influences all subsequent operation features in the meshing sequence. And this node cannot be deleted from the meshing sequence. You can also add attribute features under an operation feature node, in which case it's a local attribute feature. So it just depends how you want to scope your variables or your nodes here. So the free tetrahedral 1, the shape, we're going to highlight that now. And using this tutorial, we're only going to be interested in investigating the solder joints. So we want most of our computation cost to go to that area of interest, while we don't necessarily need as fine a resolution in the field or in the circuit board and microchip parts of this model. So they're still necessary for the overall model, but we aren't as interested with fine resolution there. So we're going to change those areas to coarser and have a finer mesh at the solder joints. Size 1. In the model builder window, right click free tetrahedral 1 and choose size. And in the settings window for size, locate the element size. So right here. From the predefined, we're going to choose coarser and then select the domain we want to apply a coarser, that level of mesh to. So instead of entire geometry, we're going to select domain and then select domains 1 through 3. So there's 1, 2, 3 here. And the only ones remaining are now the solder joints. Build all. So you can see when I hit build all, now it's built the coarser mesh on domains 1, 2, and 3, the microchip and circuit board. And the solder joints remain the normal resolution for the element size. According to the messages window, the mesh now consists of approximately 28,000 elements. So you can see down here, the timestamp in our messages, most recent timestamp says complete mesh consists of 27,660 domain elements. So we reduced it quite a bit. And for even fewer elements in the circuit board and electronic component, you can create a swept mesh. This technique sweeps a boundary mesh through the domains to create a structured mesh in the sweep direction. So the next steps are going to be, or no, I don't think we're actually doing that here. Next, we're doing the free tetrahedral on these solder joints. Okay, so it's just telling you that if you wanted to do fewer, you could use a swept mesh. I'm not going to do that here, but basically a swept mesh requires a input boundary and an output boundary, and it copies the nodes from the input side through to the output side or the target side. So if you said, you know, it depends which side you choose as the source and which is the target, it can affect the uniformity of your sweep. In this case, the domains we're talking about are rectangles, so it wouldn't especially matter. But if you had sort of a rounded shape like a semicircle or any arbitrarily complex annulus, then you'd have to start looking at your source and target and how that affects the uniformity of your sweep direction or of your swept mesh. So right now we're going to create the free tetrahedral mesh for these soldered joints. First, you can modify the free tetrahedral mesh operation to apply on the solder joints, then disable the corresponding size 1 node as it's no longer needed. So in the Model Builder window, click free tetrahedral 1. In the settings window for free tetrahedral, locate the domain selection and choose domain Now select domains 4 through 23 by removing domains 1 through 3 from selection list. So automatically it's got all the domains listed here. So I'm just going to select 1 through 3 and subtract. And what that does is remove those from the selection that we already established have a coarser mesh resolution, and it leaves the remaining 23 domains of the solder joints with this finer tetrahedral mesh. From the geometric, so we did that already. In the model builder window, right click size 1 and disable. So now we've disabled the free tetrahedral meshing for the other 3 domains because we don't need it anymore, right? We already established those domains prior. The swept mesher operates on a 3D domain by first meshing a source face and then sweeping the resulting face mesh through the domain to an opposite destination face. For straight and circular sweep paths, you can use several connected faces as source faces. All faces that encompass a domain are classified as either source faces, a destination face, or linking faces. The linking faces are the faces connecting the source and destination faces. Alright, free triangular 1. In the mesh toolbar, click boundary and choose free triangular. So now we're going up here to the mesh toolbar and looking for boundary. Gotta expand this again. Boundary, free triangular. So you can see from the options there, we had options of free triangular, free quad, mapped, or edge. So we're choosing the free triangular. And here for the sources for the swept mesh on domains 2 and 3, the upper part of the circuit board and the electronic component consist of several faces. Some of these faces are already meshed as they form the boundary to the solder joints. By meshing faces 7 and 12, you can complete the source mesh for the mesh sweep operation that will follow. And the free triangular 1 feature node is added after the free tetrahedral 1 feature node. COMSOL Multiphysics always inserts new nodes in the meshing sequence after the current feature node. To indicate the current feature node, it appears with a quadratic frame around its icon. As soon as it is inserted, the free triangular 1 node becomes the current feature. You can easily move nodes in the meshing sequence, but this could lead to build errors as operation can depend on earlier operations in the sequence. Test to move the free triangular 1 operation in the sequence. When it's saying to use the wireframe rendering to make selection easier. So the way to select wireframe rendering is this icon right here, right next to the transparency. Select boundaries 7 and 12 only. So let's see. We can flip it this way. So 12 is this, the microchip part of the geometry, and then 7 is going to be the upper boundary of the circuit board. In the settings window for free triangular, click build all. So there we go, and now it's built the free triangular only on boundaries 7 and 12. and then build all, you can see it made the triangles of the swept mesh, or the free triangular mesh, slightly larger. Not really much of a difference there. The reason is that the local coarser size attribute applies only on the interior of the meshed faces. On the edges, the mesher has to respect the already existing mesh on the solder joints. And on the outer edges, the global size settings, which is set to normal mesh size. So it's saying most of the change happened on these internal faces. So if I click undo, you can see the external field area where the solder joints aren't touching, it didn't change hardly at all. But on the inner portion, there was a much more discernible difference in the size of the triangle mesh. And that's because it's saying it's already resolved the other domains, and it's got to meet up with those boundaries, because you can't just have like a super coarse mesh meeting up with a normal mesh. It's got to resolve at that boundary. To avoid this situation, a good practice is to set the first global size setting to the coarsest mesh that you plan to have in the geometry, then specify local size feature nodes for the mesh operations that need finer mesh. So it's saying to avoid that, go from coarser to finer rather than finer to coarser, and also to define global size before local feature nodes. Okay, so in the Model Builder window under Component 1, Mesh 1, select Size, and in the settings, choose Coarser. Since the global mesh is now too coarse for the solder joints, enable the Size 1 feature under the free tetrahedral node. So if we just hit Build All, which it didn't tell us to do here because it's going to cause a error. Oh, well, it actually did it with no error, but we're going to continue here. So we need to right click on size 1. So the one we disabled before, now we're going to enable it. And in the settings window for size, locate the geometric entity selection section. So this section here. And from the selection list, choose all domains. So now we've got all 23 domains selected, and select domains 4 through 23 by removing 1 through 3 from the selection. So we selected all, then we're just going to remove the first 3. So we've only got the solder joint selected. The size attribute for the triangular mesh is no longer needed and can be removed. In the Model Builder window under Component 1, Mesh 1, Free Triangular, right-click Size 1, and delete. Now we're going to work on the Free Triangular 1 mesh. So under Mesh 1, click on Free Triangular 1, and the settings for Free Triangular, click Build All. Right, there you go. And notice that the triangular mesh is coarser this time. So now we're going to build a swept mesh. In the mesh toolbar, click Swept. And the geometric entity level list is set to remaining by default, right here, for new mesh operations. In this case, the remaining domains correspond to the domains we would like to sweep mesh. In the settings window for swept, click Build All. So the remaining domains are anything other than the solder joints. So it's created a swept mesh. And as you can see, it's got a finer resolution in the center of these domains. Basically, because it's swept, it's using the solder joints as the origin nodes or the source nodes and sweeping in the direction of the target node, so outward from the source nodes. So if these nodes where the solder joints are located are finer, then it's going to extrude or sweep those in the same pattern. So here where there aren't any solder nodes, it's a coarser mesh, and where they are, it's going to be a finer mesh. So that's a swept mesh. The mesh now consists of approximately 17,000 elements. Well, that's not exactly what mine says here. Mine says 6,877. The swept mesher used the coarser predefined mesh size to determine the number of elements along the sweep direction. For precise control of the number of elements, specify a distribution for the swept mesher. Distribution 1. Right-click Swept 1 in the Model Builder window here and choose Distribution. And now in the Settings section, in the Number of Elements text field, type 2. And then Build All. So let's see, we just changed, the only thing that changed basically was the first domain, or sorry, the domain 3, the computer chip on top of the circuit board, it just split it in half. So instead of one vertical node, now it has 2 vertical nodes. I think something went wrong here though, because my I have fewer elements than they have here, so I'm going to go back through it. Okay, so I figured out why my domains weren't matching up with the tutorial. In the free tetrahedral, all I did was, so let me go back to where I was. So under free tetrahedral size 1, I had coarser selected. So I just changed that to normal, build all, and now you have, you can see the finer resolution around where the solder joints meet that domain. And then you have to go back through to resolve the rest of the geometry. So go to free triangular, build all, and then swept 1, distribution, build all. I don't think that actually changed, but now my mesh number matches up, or the element number. Mesh consists of 20,779 domain elements. So this was a brief tutorial on meshing sequences. And if you liked it, please hit the like button, comment, and subscribe for more COMSOL tutorials. See you next time.